We know what the Great Pyramids look like from the outside, but figuring out what lies hidden inside millions of tons of solid stone has been a long-standing puzzle. Here on the Giza Plateau, three main structures dominate the skyline. The one on the far left is the Menkaure Pyramid. Standing at roughly 213 feet tall, it is the smallest of the main trio. It was built to serve as the final resting place for the pharaoh Menkaure. Its primary purpose was to house and protect a king's body, along with his funerary treasures for eternity. To provide that level of protection, the builders stacked massive blocks of limestone and granite. We are looking at millions of tons of solid rock, layered so densely that there is virtually no empty space between the stones. This historical photograph shows early excavation work at Giza. In the past, if archaeologists wanted to see inside these monuments, they had to physically dig, drill, or use dynamite. It was highly destructive, meaning much of the internal structure had to be left undisturbed. Because tearing the pyramid apart was not an option, researchers were left to guess how the internal corridors were laid out. The structure effectively became a locked black box. Recently, researchers bypassed that physical barrier entirely. They started using ground-penetrating radar and ultrasound to look inside the pyramids without moving a single stone. These tools beam energy waves directly into the masonry. Because stone has a uniform density, the waves travel through it at a predictable speed. This graph shows how the radar signals bounce back to the receiver. When the wave travels through solid rock, the return signal is steady. But if the wave hits a pocket of air, the signal changes shape, indicating a sudden drop in density. By taking millions of these readings, computers stitch the data together to map the exact coordinates, building a three-dimensional model of the interior. With enough data, the thick rock walls become transparent, allowing us to accurately map the negative space inside. When researchers applied these scanning techniques to the Menkaure Pyramid, they focused their equipment on the eastern face. This technical diagram shows the cross-section of the pyramid's layers. Behind the solid rock of the eastern wall, radar detected a major spatial anomaly, two distinct voids sitting just behind the exterior casing stones, positioned clearly apart from the known descending corridors. This visualization shows the difference between accidental internal damage and deliberate construction. A pile of collapsed rubble creates a messy, erratic density signature. These voids, however, have sharp, clean borders. The radar confirms they were built on purpose. In ancient Egyptian architecture, the eastern face of a tomb holds specific ceremonial importance. It faces the rising sun, tying the structure to the concept of rebirth and the pharaoh's journey into the afterlife. Because of their geometric shape and location on this specific side of the monument, we know these are not construction errors. They are deliberate architectural elements that have remained perfectly concealed for millennia. These twin voids point to a specific archaeological hypothesis. They may be the remnants of a secondary, concealed doorway into the pyramid. If an eastern entrance exists, it would likely connect to the known burial chambers deep beneath the structure via a network of corridors we have not yet found. Finding an untouched passageway is incredibly rare. Corridors sealed off from grave robbers and the elements often preserve pristine architectural details and undisturbed artifacts. For decades, historians relied on a specific understanding of Menkaure's tomb. This discovery indicates that the long-accepted floor plan did not account for every internal feature. The presence of these voids reveals a complex level of planning that extends deep into the pyramid's core. The construction includes a series of precisely integrated internal compartments, rather than just a uniform volume of stone. The discovery of the eastern face proves the Giza Plateau still contains unmapped spaces. By using modern physics to read the density of stone, we are finally able to